Welcome back to part 4. We're now going to look at the arc cosine. Recall that the cosine function has an amplitude of 1. Its high point is at 0. Its low point is at pi, and then it goes back to a high point at 2 pi. We need to figure out what interval we should keep so that the cosine function is 1 to 1 when we find its inverse. If I take the original cosine function and I break the cosine function at 0 to pi, then the interval that I am looking at will include the two endpoints, 0 and pi. So my domain for this function that I restrict it to is from 0 to pi. That way, when I check the horizontal line test, I can see that it passes that horizontal line test for all values between -1 and 1. Now, once I've restricted the values to the interval from 0 to pi in the x direction, I then take the line y equals x, and I reflect that interval of cosine about the line y equals x. And you can see that the new interval goes from -1 to 1 in the domain of arc cosine, and the range is from 0 to pi. Let's review the definitions now. The inverse cosine function is the function cosine to the -1, or arc cosine, with domain -1 to 1 and range 0 to pi, defined by cos to the -1 of x equals y, which also implies that cosine of y equals x. Note that some instructors and textbooks will call the inverse cosine the arc cosine, or arc cos, and then it'll have information inside. So we have the following cancellation properties. Cosine of cos inverse of x just equals x. That allows us to get the angle out. And cos inverse of cosine x equals x for 0 to pi on the interval from 0 to pi. We'll find this information very helpful for solving for angles within the function, but also when looking at domain and range restrictions. If you're going to try and memorize something about these so that you're consistently finding the correct values, you can remember that the arc cosine has domain -1 to 1 and range 0 to pi, which is the exact opposite of the regular cosine. The x and y's, or domain and ranges, are swapped.